Ring, fundamentally, is a toolkit for writing HTTP services in Clojure, or perhaps a bit less abstractly, for writing web apps in Clojure. Now, Ring was born out of a very specific need a while ago, and that need was I wanted to explore web apps in Clojure, and I wanted to run them on the great existing Java web server infrastructure. But I did not want to run my web apps in terms of the truly painful Java servlets API, which you see an example of here. Nor did I want to deploy it via the XML-based configuration that kind of dominates that scene. What I wanted was a Clojure web development story that reflected the power and simplicity and elegance of Clojure, the language. And what we came up with was something like this. And this indeed was what the original Ring looked like, and it hasn't changed much since it originally was conceived. So that's the hello world in Ring, which is just the very beginning. Ring has turned out to be quite a bit more than that, and it's grown substantially. And so what I'd like to do, instead of enumerating the things that Ring has become, is to describe how we got here. The whole point of Ring is abstraction. It turns out that a lot of nice things fall out of that. In particular, we choose the right abstractions, and we get enormous power via Clojure. And that power then, in turn, leads to better apps. So this better apps bit is actually the third thing down on the list, and that turns out to be quite important. So what I'd like to do is walk through the story then. So we start at the very beginning. This is your hello world HTTP request. This is what comes in on the socket in which we need to handle to generate a response. And what we'd like to do is take this request and apply our Clojure application logic magic and generate some sort of HTTP response, like this one. Which seems easy enough, right? That's just HTTP to Clojure and back again. The problem is that if you try to implement this directly, talking raw HTTP to Clojure, or even working this through some HTTP-specific API, you're going to be very sad. You're going to be sad because the HTTP, the protocol, is not the essence of your application. The essence of your application is more likely to be something like this, right? This is kind of the core of the business logic that you're really concerned about. And in fact, that the request looks like this coming in or the response looks like that going out aren't details that you want to be concerned with at all at the application level. So we know we need abstraction to deal with this. The immediate question is, what is that abstraction? Well, we said this was the essence of our app, right? And that should look suspiciously like a function to you. Okay, that's better. And this is getting towards what Ring is all about, where applications are functions and their requests and responses are Clojure data. But, of course, /welcome isn't all that we get in the HTTP request. There's a lot more that comes in. Basically, there are a series of named values. We have the protocol HTTP, the URI /welcome, the request method that comes along, get, and so on, the host. Now, these key value pairs suggest a very natural representation to Clojure programmers, which is a map. And indeed, in Ring, the syntax formatting is truly unfortunate here. In Ring, the requests are represented as vanilla Clojure maps. And likewise, responses, again, are abstractly sets of key value pairs. So we represent those as maps as well. In this case, we have a nested map for the HTTP headers that are going out. So then we have the request and response as data, the application as functions. So this is then basically Ring in one slide. This is the essence of Ring in terms of what the core of the protocol is all about. You have an application, which is a function. It takes a request, represented as a map, and generates a response, represented as a map. Now, this is so simple that it's almost obvious, but it's really important. It's the basis for all of the web development goodness that grows out and around of Ring. And the key is that we've taken HTTP, the protocol, and moved it into the space of the pervasive interfaces of Clojure, which are kind of functions and maps and so on. And by doing that, we get to leverage all the power that's inherent with those abstractions. So just kind of the simplest example would be pulling data out of a request. There's no HTTP-specific API here, or HTTP object, or get URI, or whatever. It's just a named value in a map, which we look up with a keyword, like we do anything else in Clojure. And that request data is, of course, a persistent Clojure data structure. So all of our HTTP manipulations are in terms of these persistent data structures. So we get functional programming by default in our web applications. And also, we get the whole Clojure library for data structure manipulation. So we get to define our web apps in terms of Clojure's powerful Clojure.core. So we talked a little bit about how the data representation is useful. We can look at the functions now. Again, the app is just a function of the request that returns a response. But typically, we'll want to build our app in layers, right? And we do that with so-called middleware. Middleware is a layer of functionality that you add around your app that basically generates a new app via higher order functions. So middleware is a higher order function of your original app that returns this augmented application that then implements some new functionality, which again is applied in exactly the same way as you did your original app, which is function invocation. So just to give an example of the kind of power that representation buys you, this is a basic skeletal middleware for a ring application. So this middleware takes the original app here as its argument and generates a new app as its return value. And that new app, again, is a function of the request. And in this case, it checks if the request is authorized. If it is, passes it back to the original app. Otherwise, it generates this 403 access denied response, which is sent to the client. We also, in addition to the function definition goodness that we get from Clojure, we also get the function composition all for free. So for example, this is a common idiom that we see with Clojure web apps. You have some core application which defines your business logic, and then you wrap a series of middlewares around it, just using the regular threading operator. So there's no special syntax or library or constructs for defining your complex web app. It's all in terms of Clojure's native functional programming infrastructure. And this is a nice little bonus that's actually underappreciated, I think, in the web development community. Because our web applications are now just functions that take and return data, they can be tested like any other function. So this is a test for the Hello World app that we had earlier. We're asserting that the app, when given the URI/welcome, returns Hello World in the body. And now this is completely orthogonal to whatever testing framework you have. It's just a function that you're testing as normal. So I think we're starting to see how choosing the right abstraction, namely Clojure's functions and maps, is lending web developers power, again, via Clojure's Clojure.core and its data structures. But I promised you this, which is a strictly stronger statement. And we get that through some leverage. And that leverage comes in the form of the Ring spec and the Ring library ecosystem. So the spec is the foundation for this. This is the document that defines how this core interaction works. In particular, it says what has to be in that request map and what has to be in that response map and how that function needs to behave and how participants in the application are allowed to modify the request and response as they flow through the application. And again, how middleware is allowed to augment and redefine app. And the Ring spec itself is very simple. Most of it's just super obvious stuff that you would expect by default. But it's really important because it facilitates this ecosystem of framework-agnostic Ring libraries. And these libraries, again, they all communicate over this protocol that's based on Clojure's core abstractions, and that's defined in the Ring spec. So everyone, including Ring itself, works through this protocol. So there's nothing special about the so-called Ring libraries other than they happen to be included in the Ring source tree, which is really just a matter of convenience of distribution. But they're here because they're sort of battery-included web development things that you would probably use in a lot of your projects. So for example, when you're doing local development, you often have different needs that you want to invoke specifically for your development purposes. So here, for example, this is something I do a lot. I have a core app, and I create a special development application that is the core app plus some middleware that will print nice stack traces on my HTML page when the application errors out, and reload all my relevant namespaces whenever a request comes in. This is stuff that you get for free with Ring, and then you can apply to any framework or whatever you happen to be using. This is another bit of functionality that's provided by Ring itself. It's a mechanism for generating responses in a functional style, in case you don't want to emit maps directly, which is reasonable, I think. This is an interesting example. It's another thing that the Ring core libraries do, which is facilitate interop when we need additional interfaces between participants. So in the case of sessions, people are going to have all kinds of random ways they want to store and retrieve their session. It might be memory or the database or a React cluster or whatever. But it'd be great if all of the participants in the Ring ecosystem could write their session using code against some common interface. And that's exactly what the Ring session library provides. So as an application or library developer, I can write session code like this, and then at runtime, the person who's deploying their app can configure the session to use whatever backend they want. And sessions are also an interesting example because they show Ring's insistence on being pervasively functional. So even sessions, which are kind of fundamentally stateful, we insist that they're represented in a functional way as a functional modification of the response, so that we ensure that Ring has really good composability and safety. And like I said, the Ring libraries are just one piece of the big and growing ecosystem. Because of the spec and the protocol that everyone shares, the entire community can participate in Ring apps as first-class citizens. So this is just a shot of our GitHub wiki, where we're keeping track of some of the things that people are developing for Ring. And these all do various different things, but what's great is that they can be composed orthogonally. So anyone can take whatever pieces of this they find compelling and stick it right into their app. And I'd like to highlight a few of the pieces that I think are particularly interesting. So the first, and the one that you would expect immediately, is what people often call frameworks, which I think is an unfortunate word because it has a bad history. But what we really mean is application composition libraries. And I think the best example of this is Clojure. Clojure is a nice little library for letting you define HTML routes and tying them to Clojure code and threading parameters that are emitted with those routes into your code. This is just a simple example that is a Clojure app. But again, Clojure just is a tool for defining these Ring functions. And you can take the result of Clojure or any other library and stick it onto any Ring adapter that you want. So here we're running our Clojure app in Jetty. And because we've defined this clean interface, this piece here is totally separable. So we can choose whatever adapter and whatever framework we are interested in. And another neat fact about Clojure, it's probably the most common answer to the question, how do I write a web app in Clojure? But the library itself is less than 200 lines of Clojure code. I think that's a really, yeah. I think that's a really neat testament to how well James has done with embracing the notion of frameworks as libraries instead of monolithic things, and how Ring helps facilitate that. So I mentioned this idea of adapters. Adapters are just the piece that actually runs your application in terms of the HTTP protocol. So typically they're just simple glue code around existing Java web servers. So the first one that I wrote, the thing that I originally wrote that eventually became Ring, is ring.adapter.jetty, which is a wrapper around the embedded Jetty web server, which is nice because it's performant, yet it's really easy to embed. But you can just as well take whatever app you have and throw in a different adapter. It's just a matter of changing a few lines of your code. Because again, they all communicate via the standard Ring interface. And there's a variety of adapters now that have sprung up. And we're only one function away from your favorite adapter there. And lastly, there's middleware. So like I said, middleware is this tool for adding layers of functionality to your application in a clean way. And we see a lot of interesting middleware popping up. What's neat is that in order to participate in the Ring ecosystem here, you just need to write one higher order function and you're in. So like Ring JSON params, it has one function, wrap JSON params, and you write that, you throw it in your app, whatever, and now you have JSON parsing into your keyword params bit in your request. So you get a lot of basic HTTP stuff via middleware that isn't framework or app specific, but what you want to share across the ecosystem. Now individually, these aren't really compelling, like basic HTTP authentication. That's pretty vanilla, right? But what's really interesting is when you have the whole ecosystem coming together around this common interface. So this is something that I copy and pasted almost directly from my most recent Ring app. And it shows how you have your core handler, that's the handler that defines like my main business logic, and then you layer on a variety of middlewares that come from all over the place and that were written by different people at different times. Some of these are from Ring core, some of these are public GitHub projects, others are things that were written specifically for the application and so on. But it's all homogeneous here. Everyone's participating as a first-class citizen equally, and it's also really clear to see exactly what's going on. There's absolutely no magic here. This is just straight-up Clojure functional composition. So I hope we're starting to see how choosing the right abstraction and using that abstraction to leverage Clojure's power is leading potentially to better web apps. We certainly have a ways to go with that, but I think we're on a great start. What I'd like to do now is generalize this a little bit. And that generalization takes us back to where we started with Ring. The key to Ring was taking the HTTP protocol and moving it into the space of Clojure's pervasive abstractions, which in this case are functions and maps. And when we did that, we got this great functional programming and composability all for free. And in particular, we defined Ring in such a way that it was cleanly composable, and furthermore, composable across kind of developers and time and libraries and frameworks, all in a clean way. And in a way that was a total natural fit with Clojure's functional programming infrastructure. And I have a very specific name for this. I call it composable abstraction. Whenever I meet a programmer, I try to sell them on this idea. And for me personally, this is the essence of Clojure. Clojure has a whole bullet point list of features, things like persistent data structures and the data structure library and the notion of value, state, and identity and sane change over time. To me, those are all just lemmas to Clojure's master theorem, which is composable abstraction. And I think that Ring does a good job of demonstrating the potential of this. So I'm interested in Ring not just as something in and of itself for this talk, but also as a potential kind of archetype for other Clojure libraries. So let's think about what is a particular example where we could use this style of library design. Well, I could give you a whole list, and I'd be happy to talk to you about it offline. But we actually don't need to go any farther than HTTP to see another great example. This was the raw protocol that we were dealing with before as the server, right? We had some request, and we wanted to generate a response in a clean, Clojure-friendly way. So we came up with this bit here. We have an app, which is a function that takes a request map as an argument and returns a response map as a result. Well, we can apply the exact same trick for HTTP clients. Boom. This is exactly how CLJ HTTP defines clients. It uses almost exactly the same protocol on the client side with a request map representing the request that it wants to send to the server. It uses some underlying adapter to send that request over the wire. It gets it back, and it parses it into a response map. And again, when we do this, we get all kinds of great things for free immediately. This is just an example of how you can implement a always authenticated HTTP client immediately in terms of Clojure's existing functional programming tools and data structures. So the net lesson there is that when you choose the right abstraction, especially one that moves us into the space of Clojure's pervasive abstractions, then we get for free, transitively, all of Clojure's awesome functional programming goodness. And that, in turn, leads to better apps. So I think that the most important lesson here is not about web development. It's about how to think about library design. And that is that if you want steps 2 and 3 here, you have to be sure to do step 1 right. Thanks, everyone.